Here we begin by checking if an ordered pair satisfies the equation. The way we're going to do that is plug in the first coordinate for x and the second coordinate for y. So here I see a y, I'm going to replace it with the y coordinate 1 equals 2 times, I'm going to replace it with the x coordinate 1 minus 3. So that tells me that 1 equals 2 times 1 gives me 2 minus 3. That tells me 1 equals, when I do 2 minus 3, I get negative 1. That is not true. 1 does not equal negative 1. For that reason, this is false. So no, it does not satisfy the equation. In problem 2, it asks us to compute the solution of the equation where it tells us one of the numbers in the ordered pair. Specifically, it gives us the value for x. So I'm going to take the equation, anywhere where I see an x, I'm going to replace it with this 2. So it's going to become y equals 4 times 2, replacing the x, plus 1. That means y equals 4 times 2 is 8, plus 1, which gives me 9. So the solution is 2, 9 as an ordered pair. Again, the way I did it is I plugged in the coordinate that I was given. If I had been given y instead, like this 9, I would have had to plug it in over here. But for the most part, you're going to be given the dependent variable, given the independent variable and asked to find the dependent variable. Here we're given the equation y equals x minus 3 and 3 inputs to put in to find the output. When we're given an input, we want to put it in for x to solve for y. So for the first one, I would get y equals negative 2 minus 3. Negative 2 minus 3 would give me negative 5. For the second one, I'd get y equals 0 minus 3. 0 minus 3 is negative 3. For the last one, I'd get y equals 7 minus 3. 7 minus 3 is 4. So again, I've put in the input wherever I see an x, and I've recorded the output as what I get for y. Same idea in problem number 4, except in the end, we're going to be asked to graph the outcome. So we start out with y equals 2x plus 2. Y equals 2 times 0 plus 2. That gives me 0 plus 2 equals 2. When I do it with 1 for x, y equals 2 times 1 plus 2. That equals 2 plus 2, which gives me 4. And finally, when I do it with 2 for x, y equals 2 times 2 plus 2, which is 4 plus 2, and gives me 6. So here we have 2, 4, and 6. If I go to graph that, I'm going to just real quick put in 5 each way. Again, apologies that this isn't going to be exactly accurate. I'm just kind of eyeballing. So the first ordered pair is 0, 2. Left, right, 0, up 2. Second ordered pair is 1, 4. Right, 1, up 4. Last one is 2, 6. Right, 2, up 6. And I could connect these into a line. When you're asked to draw the line in Webassign, just make sure that you're practicing with the tool that they give you. It's definitely a little confusing at first. Basically, you want to put one point in where you know it goes, and then drag the line in the other directions. I think you actually can do 2 anchor points and connect them as well. But basically, don't get confused with the tool. Play around with it. Ask me questions if it's not working. Same idea for number 5. We're going to start with negative 3x plus 4, put in 0, 1, and 2, and see what we get. So when we put in 0, it's negative 3 times 0 plus 4, which gives me 0 plus 4, or 4. When we then do it with 1, we get negative 3 times 1 plus 4, which gives me negative 3 plus 4, which gives me 1. Finally, when we do it for 2, we get negative 3 times 2 plus 4. Negative 3 times 2 gives me negative 6, plus 4 gives me negative 2. So now we have the points 4, 1, and negative 2. As ordered pairs, this would be 0, 4, 1, 1, 2, negative 2. So I make a quick graph. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. If I put 0, 4, I go left or right 0, up 4. 1, 1 would be right 1, up 1. And 2, negative 2 would be right 2, down 2. Connecting these in a line, it should look something like this.